one towards the other in a cyclic way, that is 1 towards 2, 2 towards 3, with a constant speed v. Find the time taken by them to meet and total distance covered. And there's also some sort of a student has to learn, then you have to apply for various situations. And there's a one initial diagram. So the person 1 is here. It's very difficult to show the person. I'll take help of the different colors. 3 persons are there. The 1 will always move towards 2. After this at t equals 0. At t equals 0, there is a position. After some time, okay, initially at instant of time, initially this will be the velocity. Then 2 will have velocity directed towards 3. 3 will have velocity directed towards 1. After some time, the 1 will be here. Okay, yeah, fine. After some time, the 1 will be here. Then where 2 will be here. So its velocity, what happened now, when it will be directed in this way, no? So here he will not be here, he will be somewhere here. 2 will be somewhere here. 3 will be somewhere here. So why can't it be on same straight line? Because when 2 comes here, its velocity should be directed in this way. So therefore he will leave this path, it has to be. So finally they will meet at centered of triangle. So how the path of this will be like this. Path of this will be like this. You can put few more dots, you'll get an exact picture. At any instant you put arrow, this velocity will be directed toward this one. Here the velocity will be directed toward this path. This will be directed toward this one, you see. This velocity here will be directed in this direction. The velocity of this red dot will be directed toward this black dot. The velocity of this dot will be directed toward this one. Well, I'll show that in the dotted line. So what's happening now? Something they are going to move in a, I think the curve little bit, this is, I'll adjust the diagram so that it will be conceptually correct. Not possible. The curve itself is wrong little bit. Okay, yeah. I think more than this I am helpless. Everything I have to set right. Like this, what happened? The triangles, there'll be other vertices of triangle, and the perimeter of the triangle will keep on decrease. Finally, they'll meet at this particular point at t equals 0. They were here, and after some time t, all will meet here. But what is the speed everywhere? The speed will be constant speed. Okay, how to calculate this time taken? I'll go for this relative velocity. What was the initial separation? It was L. So take help of this. This was V. This is 1. This is 2, no? And this is 60 degrees. This was separation L. This is at t equals 0. And finally they'll meet here. Both will be This is at t equal to 0. After some time t, there'll be a. So for your again benefit, I'm just showing the path. It'll be like this. Got it? Path of 1, path of 2. So final separation is 0, initial separation is L. So we'll go for relative velocity concept. V relative is equal to S relative by time taken. What is the V relative? V minus V sine 60. Sorry, V cos 60. V minus of final separation is 0, initial separation is L by T. So V minus of minus, this will be V by 2 equal to L. So what is the time taken will be 2L by 3V. So we are not understanding this. Relative velocity along the path, along that initial line. V cos 60 minus V. Why negative sign? If I take this is positive, V cos 60 should be negative, no? So what is the relative velocity along the initial path? Along this initial line joining 1 and 2 should be V minus of minus V cos 60. So applying the relative velocity concept. Sir, why you are taking this L? Final separation is 0, initial separation is L. What about the total distance covered? Total distance moved by each person. Total distance moved by each person or path length. That should be equal to S equal to V into T. So this will be V 2L by 3V. So this much of distance the each person will move. Path length means here like this length. Like that the persons will be there at the hexagon and they'll start moving. They'll be at a square, they'll be start moving. Try to think on them. Previously we did for 2 particles, a rocket missile. Now here I brought it for 3 particles. This is a little bit easier. Huh? Now 4 particles also you can manage. Finally they'll all meet at this particular point. So all the persons meet at centroid of triangle. Okay.
Sir, here, why is the V cos 16 negative, sir, here?
If V is positive, then V cos 60 should be negative, no? If this is positive, V cos 60 degree will be opposite to V.
Okay, sir, okay, sir. Okay.
Sir, how
Yes, sir,
L
yes,
is
sir.
positive?
How?
L is positive.
Displacement ma final separation minus initial separation.
0 minus L will come, na, sir?
No, not like that. Actually, we are discussing a relative speed here, not displacement.
Sir, L, sir, in S relative.
No, I know. It's not like V relative bar. I didn't write.
Yes, sir, okay.
Distance,
It's
relative
okay.
distance it is.
Okay, sir.
Separation, initial, like a, you mean to say like a delta S bar I didn't write, the final separation, initial separation here. So what was the separation from L? It has become 0. We are not writing displacement.
Okay, sir.
Okay, yeah. Nothing wrong, but here we are taking help of the relative speed. That's why I didn't write V relative bar. I didn't write it. Okay, sir, then how come you write it here? Relative speed is that I should take that one, no? Relative speed. Relative speed by relative separation by time taken. So this I'll write. I'll give some specific name.